Sat Shri Akal students, let's discuss straight line. Let's define and find slopes in different situations. What are the prerequisites for understanding all this? Number one is the distance formula. Well, we have studied in previous class. Let's say we have a point A and we have another point B. X1, Y1 are the coordinates of point A, and X2, Y2 are the coordinates of point B in XY plane. Right now, I can consider this axis to be x-axis and this to be y-axis. Hence, the plane on which my digital pen is writing is the XY plane. So any point I write on this plane has to be defined in terms of its abscissa and ordinate. Now, there are millions of distance between A and B. This distance, or this distance, or this distance. But when I talk about the distance between A and B, what exactly I mean by that is the shortest possible distance between A and B. And that is given by the formula AB is equal to difference of the abscissa, that is x2 minus x1 square, plus difference of ordinate and its square, y2 minus y1 square under root of this is the distance AB. This is the first formula we need to understand. The second one, area of triangle. Now, let's imagine a triangle ABC with A, B, and C as its vertices. Students, as A comes close and close to BC, the area of the triangle keeps decreasing to the extent that if A falls on BC, means A is on BC, then the triangle no longer exists. This triangle ABC doesn't exist. In other words, we can say area of the triangle reduces to 0 when the third vertex keeps coming down towards the opposite side and finally drops on the line. In this condition, we can say point A, B, and C are collinear. Now, in this case, we can say the area of the triangle is 0. So, we can always understand this to prove whether 3 points are collinear by finding the area, and in case the area is 0, the points are collinear. In any case, whether A is on BC or wherever the A is, area of the triangle ABC is equal to half the modulus, because area cannot be negative. If it's coming negative, you take the positive part, into x1 bracket y2 minus y1 plus x2 bracket y3 minus y1 plus x3 bracket y1 minus y2, and then modulus of the whole thing. This is a formula for finding the area of triangle ABC. Then these two formulae are there. The collinearity of the points, whether these points are on the same straight line or not, can be proved by 3 ways. This is a third prerequisite. Number one, by calculating the area of triangle, and in case it's coming 0, we know 3 points are collinear. Number two, is by distance formula as mentioned above. How? Let's say this is the line, points A, B, and C. In case 3 points are collinear, this distance AB plus distance BC would always be equal to AC. But students, in case B is slightly above AC, then you cannot say AB plus BC is equal to AC. In this case, you cannot say AB plus BC is equal to, reason, two sides of a triangle. Let's say this is one side, second side, and third side. Two sides of a triangle can never be equal to the third side. Two sides of a triangle, sum of two sides of a triangle would always be greater than the third side. So this is the way we take care of collinearity of 3 points by using distance formula. Now, students, having understood that these are two ways to prove the collinearity of the points, the third way is by finding the slope of line AB and BC. Let's see how. So guys, now we shift our attention to slope of a line. What's this? Well, let's say, students, we have line AB. Line AB makes angle theta with the positive x direction, positive x-axis. Tan of this theta is the slope of line AB, denoted by any letter. Let's denote by M. Now guys, let's say the line AB is lying on x-axis. This is line AB, which is lying on x-axis. What's the slope? In this case, like in trigonometry, we have understood. Let's say you draw a circle here. Now guys, let's say initially you were having a triangle. Let's say this was a triangle A, P, Q. Now this is the angle theta. Now as P moves from this point to this point to this point, what you can observe is the perpendicular is getting shortened to the extent when P drops on x-axis, the perpendicular becomes 0, and hence tan theta, which is perpendicular by base, or you can say opposite side by adjacent side, becomes 0. Now, this is x-axis, students, and let's say this is the line AQ. So AQ and x-axis are in line. They are in line, both AQ and x-axis. You can also say AQ is parallel to x-axis, or you can say AQ is part of x-axis, or you can say AQ and x-axis are same. So the slope of AQ, would be always tan theta. But since theta is 0, it's equal to tan 0. Since the opposite side of the perpendicular is vanishing, we can say slope of any line which is inclined with x-axis is 0. And also slope of a vertical line. Let's say this is vertical line AB. This line makes what angle with x-axis, students? Well, the answer is right angle. So slope of this line, slope of any vertical line is represented by tan of the angle between the line and the axis, x-axis. That is tan of 90 degree, which is not defined. Reason, when, see the last one, when P moves like this, like this, like this, and then when P comes on y-axis here, my base becomes 0. So you could say that tan 90, which is equal to sine 90 by cos 90, becomes not defined because tan 90 in this case becomes 0. So guys, we understood what is slope. The slope of a line has to do with its inclination, but slope is not inclination. Rather, slope is tan of its inclination with positive x-axis. This is a slope. The slope of a line has far-reaching understanding effects, understanding straight line and other things in mathematics. Now, let's come back to the point where we want to prove that 3 points A, B, C are collinear or not based upon slope. Before that, one more point, one more concept. Students, let's say I have 2 lines, this one and this one. Let's say this is L and this is line M. Well, students, we know in case L is parallel to M, this angle and this angle being corresponding angle will be equal. I can say this is theta and this is also theta. Or the inclination of both the lines with positive x-axis is same. Hence, slope of this is tan theta. Slope of this is also tan theta, will also be same. Means parallel lines have same slope. Based upon this, we can always define, let's say ABC is a straight line. Now the straight line can be split, thought of being split into 2 lines AB and BC. All right. Now AB and BC are part of AC. Or you can say AB is parallel to BC. Or you can say AB is parallel to BC is parallel to AC. Now guys, whatever is the slope of AC is the slope of AB is the slope of BC. Or whatever is the slope of AB is the slope of BC. So I can get an idea of proving whether these 3 points A, B, C are collinear or not by stating the slope. How? The slope of AB, if it is equal to slope of BC, So this will prove that ABC are collinear. So I've got basically three ways to prove the collinearity of a point. How, students? The first one to prove the collinearity of the points is by area of triangle. If the area of triangle is coming to be 0, 3 points are collinear. Distance formula, using the concept that if it is a triangle, the sum of these two sides will always be greater than the third side, would never be equal to third side. You can never draw a triangle, students, when two sides sum is equal to third side. For example, 5, 4, 9. It is impossible to draw this triangle because in this case 5 plus 4 is 9. You might rather say that 9 plus 4 is greater than 5 and 9 plus 5 is also greater than 4. But the third condition, there are three ways in which these three numbers can be added. The third one, 5 plus 4 is not greater than 9 but equal to 9. So you cannot make a triangle with sides 5, 4 and 9. So by distance formula also we can prove collinearity of points, and the third one is by slope, which we have just understood. If slope of the line joining points P, Q is equal to the slope of line joining points Q and Z, you can say P, Q and Z are collinear. All right. Yes, students. Now we'll take our understanding to a different level. Now we have a line, and let's say, and this line has 2 points on it. I will name one point as A and name it x1, y1. And other point B, and I'll name it x2, y2. Now, somebody asked me, find the, let's say this line is L. Find the slope of the line L. Slope of line, let's say I denote the slope by M. So in this condition, let me see once again, students. I've been given a line L. On this line L, I've been given 2 points, A and B, well-defined points. By well-defined points, I mean their abscissa and their ordinate, means their x coordinate and the y coordinate is properly defined on xy plane. So what will be the slope? So we have understood that slope is basically the angle it makes with positive x-axis and tan of that. The slope is basically not theta. Slope is tan of theta, tangent of theta. So from this, we'll have new understanding of slope. How? Now, quickly, what we do, students, we draw x and y axis also. I draw here x-axis and y-axis. This is my x-axis and this is my y-axis. Now, students, this line is making, let's imagine that this line is making angle theta with the positive x-axis. This line is making angle theta with positive x-axis. So its slope M would be tan of theta. Great. Now, students, I do some play. What do I do? I basically want to define this slope in terms of the coordinates of point A and B. I've been given 2 points. So what I do, I draw a line parallel to x-axis from point A, and I draw a line parallel to y-axis from point B. Now, if you observe, students, give me a minute. If you observe, you see this x-axis and this new line drawn, this x-axis, and I've drawn a new line. Let's say this line is M. This M. X-axis and new line are parallel, and when they are parallel, this angle will also be theta. Okay, that's great. So this angle is also theta. Now, what is this distance? Let's say this point of intersection of this line and this line is, this point is Z. This is, now what is BZ? If you observe, BZ is basically this distance, which is Y2, minus this distance, which is Y1. All right. So this distance is Y2 minus Y1. Similarly, I can say, students, this distance is Z is basically this distance x1 minus this distance x2. I'm sorry, it's x2. I'm sorry, this is x2 and this is x1. So this is x2 minus x1. And now, guys, instead of finding slope of line L, I can as well find slope of line AB. Why? Because I know AB is part of L. And once I know the slope of AB, I can always say what? The slope of AB. It's a small part of L, line L, is equal to